sometimes, so I like to use this. It's a lot more reliable. Like it always will record. Okay. So, purple, orange. Do you want to go over what we did yesterday, or do you want to just jump straight into the new stuff?
I don't think we have enough time for both.
Yeah.
So today's.
Okay. So today, what was the new thing that we learned?
Standardized scores.
Yeah, which particular one?
Z-score.
Yep. So, Z-scores, the formula for this that you need to know, really, I'm just going to open it, is equals Z-score. Okay, so like what the hell does that mean? All they're trying to do is, if this was a whole thing, they want to know from the mean how far away your score is. Like imagine, like, I don't know what you got on the, I don't know what you got on your score, actually, like your SATs, but I'm gonna say I got like maybe 600? 600, so that was my score. And all they're trying to tell is like how far that is. Like that's why it's like standard deviations, they're trying to find that. And because it's gonna be all on the same scale, like you saw today, there was orgo, or there was geology, there was history, there was English, all sorts of stuff, you know. So you gotta put them all on the same scale. And so they standardize it and they put it into a Z standardized score kind of thing. So what we need to do now is try to calculate it on the Z-score. Like this is really important. For example, like I got like a 30 out of 100 on a orgo exam, but I was still like 90th percentile. Like what? But I got like a 90 on like maybe a psychology exam, and that was like pretty typical. Everyone got a 90. So you gotta put them on like the same scale to really compare like how cool are you? Like are you at the top 9-10%, or are you like literally like everyone did better than you type beat? Okay, so this is the main one. It's just your score minus the mean, so how far you are away, and then divided by standard deviations. And standard deviations is gonna be the units. Like they're always gonna say like, how many standard deviations is your score from the mean, above or below the mean? That's what they usually say. You'll hear her say that a lot. And like in class during the first couple minutes, she uses like different terms. Like she uses like huge sentences rather than like the symbols. So you'll hear her, instead of say Z-score, she'll say like standard deviations above or below the mean. And like technically, like it is referring to this, but she says it in such like a complex way. I'm like, what the hell are you saying? So that's what she means. Okay. And they mix it up a little. They're like, okay, well, what if you had like, imagine if you had like this, and you had this, and you had this, and these were all given. But you wanted to find what's left. Oh wait, no, it would be this. Sorry. But you wanted to find this.
Yes.
Like, what would it look like? It look different.
Oh, times the thing, what is it that called? Sigma, and minus the mean, or plus the mean? Plus the mean.
Plus the mean, yeah. So to find x, you would want to do, you're so right, you would just flip that shit around, right? So it's simple math here. It's like, if we wanted to go from, I'm just gonna use black actually. I don't know why I'm being so ambitious right now. I usually color code things, but like my notes are color coded, but this is driving me insane. Okay, so like if you just had x minus mu and this equals z. But imagine you were trying to solve for that, so it would just be, it would be like z, and then this would go here, and then you would add mu. It's like switching it around a little bit. So you'll see it like that as well. And what else? Sometimes she likes it in percentile rank. Sometimes she likes it area under the curve. I know that's a lot of freaking terms, so I'm just gonna go over them right now. The light is like blinding on that part, but okay, let's see. Is that better? This is better. No, this is better. Okay, so there's z-score, and we know this is just standard deviation above or below the mean. Then today we talked about like area under the curve. And to get from this to this, it's basically the z-score, but it's translated through that little graph that we saw, where you have to choose, is it mean to, or is it beyond the mean?
Mean to would be to the left and beyond would be to the right. Is that how it works?
It would look here. I'll draw it out. So the graph is basically saying, are you trying to do, like, imagine maybe I got this score. Are you trying to go mean to?
Oh, and beyond would be like...
Because you're going to the mean,
Uh-huh.
and then beyond is like, you're not going towards the mean. No, bro, you're going beyond. You're going the other way.
Oh, okay.
So just think, are you going towards the mean, or are you going beyond the mean?
Okay.
Like, don't get it confused and be like, oh yeah, like, I'm going beyond the mean by going this way towards the mean. Like, no, fam. You're always going beyond. Okay? And it works on both ways. Here, I'll show you. Like, if you wanted it in a positive direction, like, maybe you got like a really good SAT score. You're still going mean too, you know? And then this is still beyond, away. Does that make sense?
Yes.
Yeah,
it
okay.
really does.
Slay. And essentially, like, all you're doing to get the area under the curve is you're translating like this mean score through that cool weird graph. It's like a weird ass graph. And you can go find it, it's in the end of our textbook. And then you get like I like to say like area under the curve, or it's also known as probability. Probability of that score. And she also says it is the proportion of people that got that score. Okay? So we got z-score, which is different from z area under the curve, because it goes through a little translation thing.
Yes.
It like zaps into a brand new version of itself. And then the last one she might ask for is called percentile rank. Percentile rank. And all that is it's z area under the curve times 100. Okay?
Yes.
That's all you need to know, is those three things. And there's a bunch of funky shit, like how do you choose mean to, how do you choose mean beyond? The easiest way that I've figured out is like, I made a little graph. It's like what, now let's say portion of people of blank, wait, what proportion, let me look at my notes. What proportion is blank of X score? And that sounds like super vague. She's gonna say like what proportion or percentage is above X or below X. So there's gonna be, she's gonna wanna know like, is it above or is it below? Like all the scores above or all the scores below? Below your score. Like they'll give you a score like let's say 600. And they're gonna wanna know above or below. And then the other thing you need to consider is your X. Is your X above or below the mean? I know I keep saying it and it sounds like crazy by now, but all you need to know is it is on this side or is it on this side, okay?
Mm-hmm.
So let's say it's above in this one, and let's say it's below for that one. So what you need to do for that, let me just check it, is let's draw it. So in this scenario, if this is the mean, we're saying that x is above it.
Mm-hmm.
So it would be on this side. And what proportion is above this? So that would mean that we are going to target this, right?
Yes.
It's above x. So that means that we'll want mean beyond. Does that make sense? Instead of mean the other way?
Mm-hmm.
And let's keep on with this. Let's say that our x was on the other side. It was below the mean. Below the mean. Let's say it was down here. Like that person failed the SATs. Like they were so bad. What proportion is above that person that failed? Well, that's a lot of people. That's like all of this and this. So what I like to do is I like to do 0.05 here,
Mm-hmm.
and then you're just going mean 2. Okay?
Mm-hmm.
And then the other one is what proportion is below if your thing is above. So what that would look like is, because it's your x is above, and they want to know what proportion is below you. Let's say I slayed that test, but everyone really struggled with it.
Mm-hmm.
How many people are below you? So you would still do 0.5, you're adding 0.5, and you're just doing mean 2 here.
Mm-hmm.
Mean 2. Like that. Okay?
Yes.
And so you would just do 0.5 plus the mean 2.
Mm-hmm.
But then, if your x was below the mean, imagine someone just like really failed it.
Mm-hmm.
What proportion of people got lower than that person that failed it? That's like a tiny percent. That's like that much.
Mm-hmm.
And that would be beyond the mean. Yeah. And so like I feel like I struggled the most with choosing, is it mean beyond? Is it mean 2? Do you add 5? Do you minus 5? What the hell is going on with 5? What the hell is going on with 1?
Mm-hmm.
And so I made this chart.
Wow.
And that is the only way I can solve those goddamn problems now. Thank you very much.